We believe construction processes can be faster, safer, and more precise with zero accidents. In Hong Kong, such a prosperous, highly developed city, injuries and casualties have resulted from falling concrete off facade buildings, caused by improper inspections. The facade inspections, named hammer tapping test, is one of the necessary procedures, while it is primarily conducted by human inspectors working at height in gondolas and scaffolds. It solely relies on human inspectors sweeping the facade surface with a hammer and identifying defects by hearing the tapping sound. The potential dangers of such operations at height to both the workers and public assets can as always possible, especially in unpredictable weather conditions. While tragedies happen reminds us there is something left calling for immediate attention. We introduce a facade inspection robotic system, a contact-based robotic inspection system. The robotic inspection system aims to be easy to deploy, safe to operate, capable of inspecting large and uneven facade surfaces, and able to perform a wide range of non-contact and physical contact inspection tasks. The system incorporates an end effector inspector suspended by cables from a robotic carrier on the roof. The contact-based inspector sensor on the end effector inspector can examine the health of the facade through gentle tapping actions. The high-precision sensor enables us to identify potential defects on the facade more scientifically and subjectively. A marking unit can label the identified points directly on the facade surface by programmed shapes or geometries. It can streamline the repair workflow by providing more intuitive guidelines for site workers. Effect of wind disturbancy, reaction forces from the inspection sensor and the marking unit can be effectively rejected by our thruster-based stabilizer. The robotic carrier can drive the suspending cables, controlling the height of the inspector. The mobile chassis of the robotic carrier can travel in any direction in a 2D plane, delivering the end effector inspector to any desired position of the facade for inspection. Safety is always our biggest concern, so an independent fall arresting mechanism is incorporated to ensure double protection of people's life and properties. As one of the add-on, point cloud 3D models of the buildings can be generated from flying drones. Digital reports of the facade concrete health can be provided with intuitive indications of the position of potential defects. Real site trial and experiments have been conducted to verify the performance of the system in different districts. Comparisons between inspection methods have been made, including human hammer tapping test, infrared cameras, and our contact-based robotic inspection system. Real site experiments illustrated that our sensors can identify defects similar to the results conducted by human inspectors. Compared with infrared cameras, consistent results can also be obtained, regardless of weather or sunshining conditions. The automatic workflow can keep the required manpower for robot operation minimal. In this way, the need for working at height can be circumvented